Hello there, ROS developers, and welcome to this live class number 125, where we are going to be working with a Tianbot Mini robot. And this is a part one of two live classes. It's going to have two parts. So yeah, let's go for it. Alright, so welcome everybody, welcome ROS developers to this live class. So as I was saying before, this live class is titled Remotely Control a Tianbot Mini Robot. So we are going to divide this live class series in two parts. Part one, which is going to be today, we are going to be focusing on preparing and setting up a simulation, a Gazebo simulation of the robot, so that we can test how it works, create some basic scripts to control it, etc. And then on part two of this series, we are going to actually connect to the real Tianbot robot. All right. So the guys of Tianbot have sent us this little guy here. I don't know if you can see it here. Here we have the Tianbot Mini. So yeah, basically today we are going to be working on creating and setting up a simulation in the system of this robot so that we can test it. And in part two, we are going to connect to this robot, to the real robot, and we are going to control it, of course. So yeah, lots of thanks to the people of Tianbot for sending us for free this robot, this super awesome robot. And yeah, let me not lose any more time. And with all the presentations being done, let's directly go to our PC. Let me go to my PC here. Where am I? Okay, so as always, we are going to start working on ROS-DS. Let me connect here to my account. I'm going to go right now to the live classes here section, as always. Yeah, so here in the left menu, it's going to hover. So live classes, all of you are actually here because otherwise you won't be able to see this live class because we are no longer streaming the live session in YouTube. So as you can notice, we have moved everything here. So yeah, you have to be here, yes or yes, in order to see the stream. However, we will upload later this live class as a video to YouTube. So we are recording all this live class, all this session, and we will upload it later to YouTube. All right, so that people that cannot attend for whatever the reason to this live class, they can visualize later the video in YouTube also. All right, so once we are here, all we have to do, as always, is to click here in the fork and open the class rosject. All right, this light blue button here in the upper right corner. So we have to click on this button here, and this is going to automatically copy. This is going to automatically copy the rosject to your workspace, and it's going to open it. As you can see, it's getting opened automatically. Here I have it. All right, let me make this bigger so that I can see the chat, by the way. I can see some comments here. Schmalenberg, hello, amazing. I have mine ready, rosject. Alberto, are you recording this live class? Can we see? Yes, I just talked about this a couple of minutes ago. Yes, we are recording this session and we will upload it later to YouTube. All right, so that people that cannot attend right now at this time zone for whatever the reason can also see it in YouTube later. All right, so yeah, I have already opened my rosject. So all of you guys, I'm going to show it one more time in case somebody has just arrived. So log into your Deconstruct account. Once you are logged in, come to the live classes page. Here in the left menu, select live classes. And once here, you have to click on the fork and open the class rosject. All right, and this is going to automatically copy and open the rosject for you, the rosject for today's live class. All right. So far, so good. Let me know here in the chat if you have managed to open the rosject. You should see also the notebook here opened automatically, the notebook for today's live class, which is number 125, as I have right here. Rosject and notebook opened. Great. Great. Schmallenberg. Okay. Me too, says Marco. Okay, so let's keep moving then, right? Okay, so let me explain this live class one more time, in case that somebody has just arrived. So this live class, which is called Remotely Control a Tianbot Mini Robot, is going to have two parts. All right. So today we are going to do part one, where basically we are going to focus on setting up and testing the simulation, a Gazebo simulation of the robot. As always, we recommend to start working in a simulated environment in order to test things, so that we are not going to break or cause any damage to the real robot. All right. Then once we have the simulated environment set up, we can test all our algorithms, programs, whatever we want in the simulated environment in order to make sure that they work properly and that they work as we expect them to work. Then once we have tested that they work properly, then and only then we move to the real robot, right? So this is what we are going to do in the part two. So in part two, we are going to move all the codes and everything that we have done today, and we are going to move it to the real robot. We are going to connect to a real Tianbot Mini robot in order to control it. All right? This will be in part two, which, by the way, is not going to be next week. Why? You might be asking, Alberto, why it's not going to be next week? Well, because next week we are going to have the ROS2 Learning Week. Okay? Next week is going to be the ROS2 Learning Week, which is a free event where we are going to teach every day from Monday to Friday. There is going to be like a live class every day where we are going to set up all the basics in order to start learning ROS2. Right? We are going to start by learning some basic Linux, also some basic Python programming. Then we are going to move to basic ROS2 already. Then we are going to talk a little bit of topics, and we are going to end up with a project in a real robot using ROS2, based in Python in this case. All right? So no need to register. You don't need to do any registration process. Just be sure that next week you come here you are going to see this. So next week you are going to see this panel here. From Monday, as I am saying, there's going to be one class every day from Monday to Friday. So just make sure to join the conference panel by clicking here at the time. It's going to be same time as live classes. All right, 18:00 or 6 p.m. CEST time. All right. Okay, then. I'm ready, I'm following. Okay, so yeah, then I was saying this because then the live class of the Tianbot Mini Robot Part 2 is going to be not next week, but the next one. All right, so that you have this in mind. All right, then as I was saying also at the beginning of the live class, I want to give a big shout out to the guys of Tianbot, which have sent us this, a real robot, a real Tianbot Mini robot, so that we can play a little bit with it, which is something that we love, to play with real robots. So lots of thanks to the Tianbot guys. I have left you here their page with some repos, etc., so that you can check it out. And yeah, so let's straight move to the live class. So everybody is ready. Can you give me a confirmation here in the chat so that I can keep moving forward? ready. Okay, ready. Okay, great. Then let's go for it. So the goal for this live class is to set up a simulated environment with the Tianbot Mini robot. All right, so this is the goal for today. Then let's go for it. So Tianbot, they provide a series of repos, which you can see here. Let me open them here. So they already provide a series of repositories in order to set up a Gazebo simulation. All right. In this case, we have 3 different repositories. So the first thing we are going to do is to download the repositories into our rosject. So this is a special live class in the sense that usually I already put here in the rosject some packages with simulation, with programs, etc. So usually we already have some code at the beginning of the live class. In this case, this is an empty rosject, so we don't have nothing here, okay? So this is like I have just created an empty rosject. The only thing I have done is to prepare this notebook, for sure. But for the rest, I don't have anything here. So we can open the code editor in order to check the different workspaces and everything here. You're going to see that all the workspaces, Hacking Workspace, Simulation Workspace, everything is empty. So we don't have no packages, we have nothing here. Okay, so basically what we have to do is to put something. All right, then we are going to start by downloading into our rosject these Tianbot Mini repositories. So for that, let's open a new shell. Remember to click here in the first icon, which says web shell. This is going to open a brand new web shell where we are going to be able to execute commands. So now what I'm going to do is to directly copy here from the notebook, and paste these notebooks here to the web shell, okay? In this case, not here, but I'm going to download these repositories in the simulation workspace, okay? Which is the workspace I pretend to have in order to place all the simulation related packages. So I'm going to paste the command here so that I download this repository into my simulation workspace. Okay, first command done. Let's go with the second one. And finally, the third one. All right, so now here I have these 3 repositories, Tianbot Mini Description, and Tianbot Mini Gazebo. Okay, I can also have a look at these packages here from the IDE. So if I open the simulation workspace, I'm going to see that these 3 repositories have appeared here inside my simulation workspace SRC folder. Okay, so you guys should also download and have these packages here. Yeah, so far so good. So once we have downloaded these packages, next step is to compile. So let me move here to the source of the workspace and compile. With a cat make, I'm going to compile my repository so that my new packages get compiled. All right. Okay, so in this case, nothing to be compiled. Then I'm going to source my workspace. And now I can directly launch the simulation. So I don't need to do anything else. Here I have, in the notebook, I have put the command in order to start the simulation. Okay, so within these packages that we have downloaded from the guys of Tianbot, they have already created a launch file, which is this one, which is supposed to launch to start a Gazebo simulation. All right, so we are going to directly execute this command here. So let me run it, ROS launch Tianbot Mini Gazebo simulation.launch. So this is going to start launching different things. There we go. And okay, so it seems that it has finished. So finally, now, final step is to open the GZ client in order to be able to visualize this. So for this, we are going to click on this cube-like icon that we have here. This is going to open the client of Gazebo, and we should be able to visualize here the simulation. There we go. Yeah, so let me make this big. And yeah, so here we have a Gazebo simulation of a quite simple environment here with a couple of rooms. And you might think, hey, Alberto, but the robot is not there, right? I guess that some of you are thinking this. Hey, Alberto, but the robot is not there. That's not true. The robot is there. But as I have shown at the beginning, this robot is called Mini for a reason, for a good reason. It's a very small robot. So the robot actually is here, but we have to zoom in order to properly visualize it. So let me zoom in, and there we have it. So here we have the Tianbot robot, okay? Here we have the little guy. There is a, by the way, let me tell you that there is a small book here in the simulation, which is that the robot does a slow movement, has a bit of rotation. Okay, probably this is related to the muse, to the I don't know the word now, to the frictions, okay, between the wheels and the friction coefficients between the wheels and the ground and the environment. Okay. However, don't worry, you are just going to see that the robot moves a little bit like this. No big deal. Okay. So yeah, here we have the simulation. We have successfully started the simulation for the Tianbot Robot Mini, and we could start already working with it, trying to move it, to visualize the laser, etc. However, we are not going to do this yet. Let me... Okay. There we go. Okay. Let me check here again. There are some messages. So what's the problem here? Oh yeah, so you have like two SRCs. Yeah, you have to remove this one. Remove this SRC and just put everything in the first one. Okay, yeah, it doesn't matter because there was nothing for make to compile. Yeah, in this case, there is nothing to compile. So yeah, it's not that important. Okay, then, okay, so we have launched the Gazebo simulation, but we are not going to start working now with this simulation. Why? Why I'm not going to start working with this simulation? So let me give you a hint. So as I have already said many times, in the part 2 of this live class series, our goal is to actually connect and control to the real robot. Then this real robot, we are going to put it in our real robot lab, which, by the way, if you don't know it, here in our main page, you can come again here to the left menu and open the real robot lab, which is our lab for remotely controlling a robot. So basically here, what we are going to do is to put the Tianbot robot that Tianbot has sent to us, we are going to put it here in this environment. Currently here we have a Turtlebot 3, but for this live class, for testing this Tianbot Mini robot, we are going to remove the Turtlebot 3 and we are going to place the Tianbot robot here in this environment, this real robot in our real robot lab. Okay, so having said this, what do you think we would need to change in our simulated environment in order to properly test the Tianbot Robot Mini, taking into account, of course, our final goal, which is to control the robot in the real robot lab? What do you say? Nobody? No? Okay, very well. We should test it in the simulation of the real environment first. That's right, okay? So we could start testing here, okay? But it makes no sense, actually. Okay, we could do it in order to test some functionalities of the robot itself, but since our final goal is to put the robot here in the real robot lab and control it here, I think that a better approach would be to perform our tests in a simulation environment which actually is like our real robot lab. And we actually have a simulation, a world, a Gazebo world, which is like our real robot lab. So, in fact, it makes much more sense to test the robot in this world, right? This way, we are going to make sure that our simulation tests are done in an environment which is close to the real environment that we are going to be working with, right? So, next thing we are going to do is I'm going to stop this launch, and I'm going to download one extra package, which I have here, okay? So I'm going to download this repository, which is ours in this case, which is the Real Robot Lab Simulation repository. So I'm going to copy this command, and I'm going to download here inside the SRC folder. I'm going to download here the repository. There we go. And why I am downloading this repository? Well, because inside this repository is where I have the world of the Real Robot Lab. Okay, here inside the worlds folder, I have several worlds, and they include this world, the world of the Real Robot Lab. All right? Then, once I have downloaded this repository, what I'm going to do is to modify the simulation launch file, which I have run right before in order to start the simulation. So this file, I'm going to find it here inside the Tianbot Mini Gazebo package. So let me open this package, Tianbot Mini Gazebo. There we go. Inside the launch folder, we have this simulation.launch file. Okay, so let me actually open this launch file. I don't like very much this, by the way. Okay, let me reorganize this a bit. There we go. Okay, so what I'm going to do is to open this simulation.launch file, and inside here, I'm going to modify the world that I am launching. Okay? Currently, as you can see here, the world which is being launched is this one, this room mini.world. Okay? So what I'm going to do is to substitute this world by the Real Robot Lab world. Okay? This world is called like this, Real Robot Lab _v1.world, and it is contained inside this Real Robot Lab package. So basically what we are going to do, we can actually directly copy this line here from the notebook and substitute this line here, okay? So actually I'm going to do that. I'm not going to remove it, I'm going to just comment it, because maybe in the future I'd like to come back to this world. So I'm just going to comment it here in the launch file, and I'm going to paste here the new world, the Real Robot Lab world. All right. So let me save this. And now I'm going to launch one more time this launch file. I'm going to run it one more time. And now what I expect is to see the Tianbot Mini robot in the real robot lab. So let's see what we get. And there we go. Okay, so actually here it's spawning at the center of the simulation, which I am not liking very much. So I'm going to do a quick change here. Okay, this is not mandatory, but I'm going to do it. So let me stop this. Then there is a way in which we can control where the robot spawns. So let me minimize this so that I can work better. Okay, so basically we can have a look, for instance, here at another world which uses this, which is this the real robot lab package, the main.launch file. Here we have it. Put robot in world. Let me open about 3 Gazebo, put robot in world. Okay, let me have a quick look. Oh, I don't have it here. Okay, in any case, I'm not going to probably. Okay, no worries. Let's forget about this. I'm not going to do it now because probably you are going to get lost and it's not that important. So let me just relaunch it and I'm going to move it directly here through the client. So I'm going to select the robot here and I'm going to move it, let's say, here. Okay, there we go. All right, so you can do this if you want. So let me recover my chat. I don't want to miss anything that you say. Okay. All right, so yeah, we are ready. We have launched the Tianbot Robot Mini in our world, which resembles the real robot lab, as you can see. Yeah? Okay, so we are ready. We have set up our simulation, which is the first step. So now the next step is going to be to actually test the different functionalities of the robot. We have to test if we can move properly the robot, if we can read the laser readings. By the way, this robot, although it is super small, it contains a LiDAR, which is super cool and gives the robot a lot of possibilities. All right, so here we have the LiDAR, which is going to allow us to get these laser readings and better understand the environment. All right, super useful. So we have to test all these. We have to test if the laser works properly. We can read. If we can read the laser values, if we can actually control the wheels in order to move the robot, etc., etc. So that's what we are going to do right now. Then, first thing that we are going to do is to execute our ROS topic list. Why? Because this way we are going to know what topics we have available. All right? So let me, right now here, actually, I'm going to open a new shell here. Let me open a new one. And I'm going to run a ROS topic list. Okay? So basically here I'm going to see different topics. Some of them related to Gazebo, clock, calibration, the overlord, which actually this topic is not related to the robot itself, but to the environment. And we can see an scan topic. We can also see a TF topic. We can see a command belt topic, super important, because we know that usually command belt topics are used in order to move, to send velocities to the robot. we can also see an ODOM topic. Yeah, so basically we have these three topics. We can see these three topics which are the most important, probably at this point. So the scan topic is the topic where we are going to be able to read the laser readings. Okay, we can do very quickly a ROS topic echo to this scan topic. And we can see that the topic is working and it's being published there. All right, so if we do an info here of the scan topic, we're going to see that actually in this case, Gazebo is publishing. It's publishing laser scan messages. All right, we can see here the values of the laser, etc. All right, so we can see that the laser topic, which is this scan topic, is working properly. We also have this Tianbot Mini command bell, which we know that usually, let's get some info about this topic. Tianbot Mini command bell. So we can see that this topic, currently there is no publisher, and it receives twist messages. All right. So if I publish a twist message into this topic, I should expect to move the robot, right? So what I'm going to do is to test this right now. So I'm going to rotate the robot to the left. Let me reorganize this a little bit. There we go. Okay, so I'm going to publish a twist message directly here into the topic. Let me close this. Okay. Tianbot Mini. Okay. Stop this. Okay, thank you. Geometry messages, twist message. I'm going to autofill and then I'm going to give here a value in the Z, let's say 0.2, for instance. And frequency of 1 Hz, for instance. Then, if I run this, I should expect to start see the robot rotate at a faster velocity, of course. So let me run it. And we can see now how the robot is starting to rotate to the left in this case, okay? In case I change the value here to minus 0.2, then it's going to start rotating. It should start rotating to the right side. Let's see. There we go. Okay? And if I publish a 0, of course, it's going to stop. There we have it. Okay? All right, great. So we have just tested that the command bell topic also works. So we can move, we can control the robot by publishing into this Tianbot Mini command bell topic. All right. Then finally, we have also this ODOM topic, right? This Tianbot Mini ODOM. ROS Topic List. Yeah, this Tianbot Mini ODOM. So let's try to get some information about this one. So we can see that actually also Gazebo is publishing into this ODOM topic, and it's publishing messages of the type odometry. All right. So basically here in this topic, we are going to be able to get information about the position and orientation of the robot, the pose of the robot. Okay. So if we subscribe to this topic using a ROS topic echo, we can actually get information, as we can see, about the pose, the position and orientation of our robot. All right, so super useful topic also, this Tianbot Mini ODOM. All right, have you been able to test all this? Let me know here in the chat. So far, so good. Everything is working. Are you testing the simulation? Everything is working for you as well? All good. Okay, excellent, excellent. So yeah, apparently everything is working fine. So let's keep testing. Then another thing that we can do is to try to visualize some of the things using RVs. All right. So let me launch RVs right now. And I'm going to try to visualize, for instance, the laser in RVs. Okay, so here I have launched RVs. then in order to be able to see their RVs window, we have to open the graphical tools. So I'm going to do this right now. And here I have RVs. So what I'm going to do right now is to, let me first of all maximize this so that I can see it better. Then I'm going to change the fixed frame, okay? This is important. Let's change the fixed frame to base link. There we go. Then I'm going to add, first of all, a robot model so that I can see the robot. A robot model display. There we have it. Let me get closer to it. Okay, here I have it. And then I'm going to add, for instance, a laser scan display. So let me look for it here. Here I have it, laser scan. And I'm going to configure the topic name to scan, which actually is the topic that we are using in our simulation. So now I can actually see here the laser readings, which basically are detecting this environment. All right, let me put this here. All right, so I can get the laser readings. Also, another thing that I can test here using RVs is, for instance, the odometry. So I can also add an odometry display. Here I have it, odometry, and set it to the Tianbot Mini odom topic, so that I can also see here the odometry of the robot. All right. Okay, so far so good. Everything seems to be working. We have checked it directly on the topics. We have checked the different topics here using RVs. Everything is working as expected. Great, so let's keep moving forward. Then these repos that we have downloaded, these repos from Tianbot, these three repos, Tianbot Mini description, and Tianbot Mini Gazebo, also include some very interesting practical demos. All right, so we are going to demos and pre-configured programs. Okay, so one of these programs is the very useful and very common teleop program. Okay, so here inside the Tianbot Mini package, actually if we open it here in the IDE, we are going to see that it has different launches. These basically are the teleop and some navigation related demos, which we are going to see in a moment. But we are going to start by testing the teleop program. Okay, so basically this teleop program is going to allow us to control the robot using the keyboard. So let me copy the command here from the notebook and paste it here. And as you can see now, using these keys from the keyboard that we have here, we can remotely control the robot. All right, so let me put here the simulation. I'm going to make it a bit bigger, get a bit closer. There we go. Okay, so now here, by having the focus on this shell and pressing on the certain keys, for instance, the key I is going to move the robot forward. The key here, comma, is going to move backward. The key J is going to rotate to the left. The key L is going to rotate to the right, etc. Okay, so by pressing these keys, I'm going to do it right now, I am able to control the robot using the keyboard. So I am able to, in a very easy way, teleoperate this robot, as you can see. So very useful program, very basic program, also, but very, 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 very useful. Okay, because it allows me to control the robot in a very easy and intuitive way, without having to publish messages into the topic directly, etc. All right, so I'm going to stop it. In order to stop it, it's the key K. All right, there we go. Okay, so very interesting demo. Then there is another very interesting demo, which is actually a SLAM system. So we can actually launch a SLAM system for this robot. Yeah, so this is huge because it's a very small robot, but due to the fact that it has a laser it is able to provide a very accurate SLAM, all right, simultaneous localization and mapping. So we are going to actually test the system by launching this launch file, the slam.launch. So let me copy it again directly here from the notebook and paste it and execute it. Okay, so here I am launching the SLAM system. So now, in order to properly visualize this, as it is shown here in the notebook, we have to, again, go to RVs, okay? So here we can see in RVs, our robot with the laser readings, and actually how it is creating a map of the environment, yeah? So this white area that we have here, basically, it is the map, a 2D map that it's being generated right now by the robot, yeah, using the laser readings. But that's not all. We can actually also send goals to the robot, okay? So I can, right now, send a goal to the robot using here the RV's 2D nav goal tool. So let's send it, for instance, here to this unexplored area. As you can see, this area of the map, this corner has not been generated. So I'm going to send it to this area so that it generates this missing part of the map using the 2D nav goal tool. So I'm going to click here in RVs, in the 2D nav goal tool, and I'm going to send the robot here. And as you can see, the path is generated and the robot starts going to that area. All right. There we have it. And it rotates there. And in RVs, we can see how now it creates this area, okay? So now it has completed the map. And we can send as many goals as we want. So we can send another goal to this area now, and the robot is going to start planning and going to this section, okay? So again, we can confirm that the SLAM demo is working as expected. So we can generate a map of the environment we have the robot in, which is super useful, and we can also send goals. Okay, we can send goals to a robot in order to send it to a specific location. Let me send one last goal here. Let me send it here and see how it goes through the middle. Okay, so yeah, we can send goals to robots. So the navigation system is also working out of the shell. Yeah, so all I have done is to download the repositories here to the rosject. So everything is working out of the shelf. So it's great. Okay, so have you been able to test these demos also? These the teleoperation program, the SLAM system. Everything is working good as well. Any issues here? Yes, SLAM is working. Okay. Yeah, that's great. That's great. Super cool demonstration, which is working out of the shell without having to change anything. How does the 2D navigation work? Well, that's a very complex question to be answered here in a live class, Schmallenberg. However, basically what is happening here, most of the things are based on the laser, okay? So using the laser, which are these red things that we have here, if I disconnect here the laser from RVs, you're going to see that these red lines disappear. See? Now I'm going to activate again the laser. So basically, using the laser readings, the robot calculates its position. Yeah, so it calculates its position in the map. Okay? Then we can send goals with reference to this map, and then a path planning system. I don't know which one we are using here, probably DWA, NAVFN in this case. This is the global planner. Then we have also the local planner, which is the trajectory planner in this case, calculates the local trajectory, so lots of things. if you so it uses this. It uses basically two things: the global planner and the local planner. Okay, basically it uses these two planners. Let me tell you, Schmalenberg, that in case you want to learn more about this, because it's too much to be answered here in a live class, we have some courses. We have a couple of courses that are related to this. One of them is the navigation, ROS navigation in 5 days. In this course, basically, you are going to learn step by step how all this works, all the mapping process, the localization process, and also the path planning process. You're going to learn how all this works from a ROS point of view, okay? But also we have the path planning basics course, which goes more deep into how the algorithms of the path planning work, all right? So have a look at these courses. If you want to learn more about this, I suggest that you have a look at these courses. Okay, so let me stop the Slam demo. All right, so one more thing. Basically, we have done several tests already for the whole robot, all the systems, the laser, the odometry, the differential drive controller in this case, so that we can control and move the robot and send velocities to the wheels. So in order to finish our test, we are going to create our own program. Okay, we are going to create a Python script, a simple Python script, in order to combine sending command bell velocities, so moving the robot, with listening and reading data from the laser. All right, so in this case, we are going to create a new folder named scripts inside the Tianbot Mini package. All right, so this Tianbot Mini package is this package where we have all these demos and everything. Okay, so inside this package, I'm going to create a new folder, which I'm going to name scripts. And inside this script, I'm going to create a Python script. Let me name it test, for instance. Test.py. There we go. Okay, then inside this Python script that I have created here inside the scripts folder, we are going to paste the code here that we have in the notebook. So let me select the whole code, copy it, and paste it here into my script in the IDE. Okay, so now here I have my Python script, which we are going to review in a moment. Then one more thing that we are going to need to do is to give execution permissions to this script. So let me very quickly come here to this package, simulation workspace src. Then I have to go inside the Tianbot Mini scripts folder, and here I have the test.py. So now I'm going to give execution permissions to this script with this command. Actually, I'm going to copy and paste this command here because I don't have it in the notebook. So I'm going to paste it here in the chat so that you can also copy directly from here, okay? So this command basically is going to give execution permissions to this script. Now, as you can see, it's going to show up in green color, which means that it has execution permissions, okay? All right, so let's have a quick look at this script before running it. So super simple. We are importing the required messages, which in this case are twist in order to communicate with the command bell topic, and laser scan in order to communicate, to read, in this case, the data from the scan topic. And then I have created a very basic Python class, which is called Tianbot. I define here a ROS publisher in order to publish into this topic, command bell topic. I define a subscriber, a ROS subscriber, in order to read the messages that are published into the scan topic. I define a couple of messages for the laser and for the twist. I define a rate, and here basically I'm just I have placed a wait for message function so that it's going to wait here until I start receiving data into the scan topic, all right? Then I have the laser callback function for this subscriber. So every time a new message is published into the scan topic, I'm going to save this message into this laser message variable, attribute of the class in this case, all right? So in this attribute, this self.laserMessage, I'm going to have all the data from the laser constantly being updated, all right? So I will be able to access this data using this class attribute, laser_message. And then I have here the move laser function, which basically uses a very simple logic. So basically here I have a couple of prints in order to print the value of the front laser. So basically here I am evaluating the reading from the front laser. Yeah, which is the front laser? Well, the front laser is the laser which is pointing to the front of the robot, which in this case it's this direction. All right? So in this case, our laser has 360 different beams, let's say, which contain data. Yeah, they are covering, as you have seen in RVs previously, they are covering 360 degrees. So they are covering all around the robot. However, if I want to know the data specifically of the front of the robot, then I have to access some specific beams. In this case, the beam in the position 180 is going to give me the data of the laser reading right in front of the robot. So this is the reading that I'm going to be evaluating in my function, okay? Then, as far as this value is higher, as you can see here, than 0.3 meters, I'm going to move the robot forward in the linear X component. I'm going to move the robot forward at a speed of 0.2 meters per second, okay? Then once the value of the laser reading in front of the robot gets lower than 0.3 meters, so it is detecting an obstacle or something which is closer than 0.3 meters, then I'm going to completely stop the robot. Okay? So as you can see, it's a very simple logic. Basically, what I'm expecting with this program is I'm going to start moving the robot forward, all right? And then once the robot gets too close to a wall, closer than 0.3 meters, in this case, the robot is going to stop. Okay, so very simple logic, very simple program, but it's going to allow us to test a little bit the robot and its functionalities from a Python script. All right? Then, yeah, in the main, basically, I'm just generating the ROS node, and I create an object of the class, an instance of the class, and then I call the move laser function, which is the function that contains the logic. All right? So, yeah, let me shut up right now and test this program. So, let me, first of all, I'm going to come a bit closer here. There we go. I'm going to launch, in fact, the teleop so that I can put the robot heading towards, let me move it a little bit here. Okay, it's still launching. So let me put the robot no, not here. Here. Okay. Yeah, let me put it here, for instance. Okay, so now I'm going to launch my script. So ROS run Tianbot Mini test.py. In my case, I have named it test.py. Okay, maybe you have named it with a different name. So I'm going to run it. So what I expect is that the robot starts moving forward, until it gets too close to this wall that we have here, and then it's going to stop. So let me run my script and see if it actually does this behavior. So now it should start moving forward. There we have it. We can read here the laser readings. Right now are 1 meter, which are going to start getting lower, by the way, 0.8. So once this value gets lower than 0.3, the robot is going to stop, which is going to be soon. 0.4 now. Okay, now, so now the reading has gone under 0.3, which is the logic of our program. So the robot has at this point stopped. All right? Okay, great. So yeah, basically that's it. We have completed the notebook. We have completed our goal, which basically was first to set up a simulation of the Tianbot Mini robot in Gazebo. We have done that. We have set the simulation and the robot actually to a world which is like our real robot lab. Okay, so that the simulated environment that we are testing and the real environment that we will be working with are very close. And yeah, basically have tested all the functionalities of the robot. I can move it, I can read the laser, I can read the odometry data, I can use a teleop program, I can launch a SLAM system. So basically everything is working. So at this point, I would say that we are ready to move to the real robot and to actually work with the real robot. All right, so that's what we are going to do in part 2, in the next live class. Okay, so for this, that's it. So I'm going to leave it here. I don't know if you want to do any comment or anything in the chat here before we close. Great class again. Thank you. Thank you very much, Schmallenberg. Thank you very much for your nice words. All right, so yeah, remember, before I close, next week we are going to have the ROS2 Learning Week. So it's going to be like a live class every day from Monday to Friday. We're going to have at the same time a class where we are going to basically teach all the basics and the foundations of ROS2 with Python. Okay, it's a completely free event like the live classes. So you just have to join the conference in time. All right. So, and then this is going to be for next week. And then the next week we are going to do part 2 of today's live class. So we will do part 2 of today's live class where we are going to actually connect to the real robot. This guy, let me change already the screen. This guy that I have here, that the people of Tianbot sent us. So actually we are going to connect using the real robot lab to this robot, and we are going to test all the functionalities with the real robot, and we are going to also create a Python script in order to control it, like we have done right now in the simulated environment. All right, so yeah, that's all for today's live class. Thank you very much for being here with me another day. I really hope that you have enjoyed it, you have liked it, and that you have learned something. And yeah, in this case, I will see you next week, next Monday, 6 p.m. CEST time, with the first day of the ROS2 Learning Week. So until then, as always, take care and keep pushing your ROS learning. Bye-bye.
What are you doing, Alberto?
I'm training this intern with ROS.
Oof. Did you have the same experience? Spending too much time equipping your team with ROS skills? Check out our ROS Online training solution for enterprises. A fast and easy way to empower your team with ROS.
From ROS basics to manipulation, perception, AI, ROS2, everything your team needs to learn is here. Practice with real and simulated robots. Train your team by doing from day one. Also, our ROS experts will provide you 1 hour of consulting services to boost your robotics projects.
Want to become a happy Alberto? Request a demo today.